Good morning, everybody. Let us discuss phase diagram today. In this session, we'll discuss mainly the phase diagram of water system. In order to understand phase diagram of water system, let us understand what is phase and what is phase rule. The phase is, by definition, an expression that deduces purely from thermodynamic consideration by Willard Gibbs in 1876. It explains the behavior of heterogeneous system in equilibrium. Phase rule as derived by Gibbs is P plus F is equal to C plus 2 or F is equal to C minus P plus 2, where F is the number of degrees of freedom, C is number of components, and P stands for number of phases. Phase rule states that every homogeneous or heterogeneous system in equilibrium, the sum of number of phases and degrees of freedom is greater than the number of components by 2. That is, F is equal to C minus P plus 2. The term phase is defined as any homogeneous and physically distinct part of a system having all physical and chemical properties the same throughout. For heterogeneous system, systems will have 2 or more phases. In case of water, there is only one phase, and but it can able to exist in 3 forms, that is solid ice, liquid water, and water vapor. Altogether, it has 3 phases. Component is defined as the least number of independent chemical constituents by means of which the composition of each phase of a system can be expressed in the form of chemical equation. And this is denoted by the formula C is equal to N minus E, where N stands for number of chemical species, E stands for the number of independent chemical equation relating their concentrations. Example for one component system is pure water, and example for two component system is salt water or sodium chloride and water. Example for three component system is systems with a combination of iron, water and hydrogen. As far as the degrees of freedom or variance is concerned, it is defined as the smallest number of intensive variables such as temperature, pressure and concentration that can be changed independently without disturbing the number of phases in equilibrium. And a system, if it has only 1 degree of freedom, we call it as univariant, and if 2 degrees of freedom, we call it as bivariant, and if it has no degrees of freedom, it is called as invariant system. The advantages of phase rule is it provides convenient method of classification of equilibrium states of system. It predicts the behavior of system with changes in the intensive variables, indicate that different systems having the same number of degrees of freedom behave in the same manner. Applicable to macroscopic systems. It takes no account of nature of reactant and products in phase. It's applicable to physical and chemical equilibrium. The limitations of phase rule is it is applicable only for the systems in equilibrium, applicable to a single equilibrium state, considers only intensive variables, consider only number of phases, not quantity of phases. It requires that all the phases to be present under the same conditions of temperature and pressure. Phase diagram of water system could be explained, or it is a graphical representation formed by plotting the values of intensive variables such as temperature and pressure for the equilibrium conditions between two phases. It shows the properties such as melting point, boiling point, phase transition point and triple point. The complexity of phase diagram increases with increase in number of components in the system. For a simple substance, Say for example, if it is an one component system, phase diagram is two-dimensional, which is a plot where pressure and temperature are independent variables. The phase diagram of two component system is a three-dimensional plot where third axis is for composition. The three-dimensional plot can be converted into two-dimensional plot by keeping one variable constant. When one of the variable is kept constant, then the phase rule equation is reduced to F is equal to C minus P plus 1. This is known as reduced phase rule. The phase diagram of water is shown like this. It has three phases: the solid phase, liquid phase and the vapor phase. And this is a mere plotting of temperature versus pressure. So the curve BO is called as the sublimation curve, and the curve OC is called as the melting curve, and the curve OA is called as the vaporization curve. And there is a curve which is extending from curve OA, which is called OA dash, which is a metastable curve. And the area, that is A dash OC, has, or it is almost in the solid state, and the area above the curve AOC will be in the liquid state, and the curve BOA below that you can able to see the gaseous phase. So water system actually fit into the formula F is equal to C minus P plus 2, and we can able to find out the number of phases, components as well as the degrees of freedom. So as far as you consider the melting curve OC, that shows as melting point curve or freezing point curve, or it is called as the fusion curve. It represents the equilibrium between ice and water. It's enough to know either temperature or pressure because other variable gets automatically fixed. At atmospheric pressure, ice and water can be in equilibrium only at one temperature, that is at freezing point of water. Thus, ice, water, equilibrium line, that is curve OC, has only 1 degrees of freedom. And similarly, we have the vaporization curve, that is curve OA. This curve is denoted as OA and has only 1 degree of freedom. Therefore, the system is said to be univariant. The vaporization curve or the vapor pressure curve, which is called as OA dash, represents the metastable equilibrium. Under some special conditions, pure water may be cooled down much below the freezing point without forming ice. Thus, it's possible to extend vapor pressure curve even below freezing point of water. This equilibrium can be approached by cooling liquid water and not the heating ice. Metastable vapor phase can be few important terms in the case of phase diagram of water is critical point, which is a point on a phase diagram at which both the liquid and gaseous phases of a substance have the same density and are therefore indistinguishable. Triple point is a temperature and pressure at which a substance can exist in equilibrium in the liquid, solid and gaseous states. Triple point of water is at 0.01 degree centigrade and 4.58 millimeter of mercury. Thank you.